All right, page 17. If you've read the question, we have a water tank that holds 1,200 gallons at time 0, and during our time interval, we have water being pumped into the tank at this rate, and it's being removed from the tank at this rate. So that's what we were given. Now, what you want to pay attention to, these are the equations that they would be written as on the AP test. What I did was over here, I typed them up exactly as you want to put them in your calculator. So you got to watch out for those parentheses. Let's get started. I also, on my calculator, I have the rate in, which is W, that's your in. That is the blue graph on here, and the rate out, that water is being pumped out, is the red graph on here. So again, I'm just jotting those to myself so I can distinguish between the two. The window on my calculator, this is the window I have. The domain, they gave me 0 to 18, so I went 0 to 19 just to give myself a little buffer on the end. And then for the Y's, I'm just playing around with the numbers, negative 100 to 300 fits. It took me a couple tries, so I think I went up to 1,000 first and realized that was too high on the y-axis, and I brought it back down. So just give it a try and see what you can do. Is the amount of water in the tank increasing at 15, why or why not? Well, what I want to do is compare the rates. These are the rates on my calculator. So if I look at this, at 15, if you hit trace and then type in 15, that's where I'm looking. So that is my in. That's the rate at which it's going in. Now if I hit the up arrow, that's the value of 15. That's what I'm looking at for, I can compare the two. So at 15, I'm bouncing between this. So what's happening faster? If you look at this, the red graph is higher, so out is faster. So at time 15, the water is being removed faster than it's entering the tank, and therefore, the amount of water is not increasing, okay? So I can say that W of 15, the rate in is less than R of 15, the rate out. So this is happening faster. So is the amount of water in the tank increasing? No. Water being removed faster. Okay, something like that. To the nearest whole number, how many gallons of water are in the tank at 18? So that's a new time for me. So if I want to find the amount of gallons in the tank after 18 hours, then I need to know how many gallons I start with. That's 1,200, plus I need to add up, integrate, from 0 to 18, all the water that's going in minus all the water that's going out. So what I did is on my calculator, I have, and I just realized I zoomed in on my paper, so you might not be able to see all that. On the calculator, I've already put into Y3, Y1 minus Y2. So I'm going to turn the other two graphs off, turn Y1 minus Y2 on, second trace, option 7, it's going to graph, and then I have to enter my lower limit and my upper limit to get the integral. This becomes 1,200 plus, this is 109.788. So when I get that, I add it all up. It says to the nearest whole number, make sure you are rounding, 1,310 gallons. So that's what you'll get on your calculator, okay? For part C, at what time on my interval is the amount of water in the tank an absolute minimum? If you recall, when we have a closed interval and when they talk about an absolute minimum, that means endpoints become contenders as an answer. So what I want to look at, the amount of water, so I can say, let's see here, up here I talked about G representing the amount of water in the tank. So I'm going to say G is an absolute min when the derivative is 0 or d/e, and we have to have a sign change, negative to positive. That's going to give me my minimum. Now, if we think about this, if this is how I find the amount of gallons of water, the derivative of this, the derivative of 1,200, is 0. Derivative of an integral, it cancels. So G prime, if we talk about that, that's just W minus R. When does that equal 0 or d/e? So that's what we're talking about. So I want to do a G prime number line from 0 to 18. So I need to find, this is my Y1 minus Y2. So if I want to find my zeros, second trace, Option 2, left bound, right bound. My first x-intercept is 6.495, and I'm going to do that again on the second one, and I've got 12.975. Now my graph is below, above, below, therefore my signs negative, positive, negative. Now this is where you have to be careful. My graph, therefore, the amount of water is decreasing, increasing, decreasing. I could have an absolute min at 6.495 or at 18. So what I need to do is compare how much water is actually in the tank during each of those times to see which one is actually the absolute minimum. Now luckily I know after 18 hours there's 1,310 gallons of water in the tank because that's what I did in Part B. What I need to do is find out what's happening when T is 6.495. So everything I did in Part B, I now have to do again at this new time. So 1,200 plus the integral from 0 to 6.495 of W of T minus R of T. And I want to get this answer. So I'm going to integrate. Lower limit is 0. The upper limit, 6.495. Let's see what that is. There we go. Calculator's a little slow. And so I have my answer there, and what I want to do is add 1,200 to that. And I've got 525.242. That's how many gallons. Therefore, I'm going to put this, I guess, right in the middle of the page. Therefore, absolute min is at T equals 6.495 hours. So that's your final answer for that. Part D. When T is greater than 18, no water is pumped into the tank, but water continues to be removed at the rate of R of T until the tank is empty. Let K be the time at which the tank becomes empty. Write, but do not solve, an equation involving an integral, that's important, that can be used to find the value of K. So what I want to do, at 18 hours, this was a key time that we've already used up here. At 18 hours, we know how much water is in the tank. So if I want the tank to be empty, I need 1,310 gallons of water to be removed from the tank. So what I'm looking at, if it's empty, and this is kind of like my scrap work here, if the tank is empty, that means I need to remove 1,310 gallons. That's my goal. So I need an integral expression to set that up. I also have to use K because they talked about that time. Okay? So what I'm going to look at, I want to add up, integrate, the water being removed, that's R of T. Now this is after 18 hours. From 18 to sometime K, whatever that time is, that's when it's empty. And the amount of water that has to be removed has to equal 1,310. Because if I remove that much water, then the tank is empty. That is one way you can write it. There are other expressions, or you can write some other, you can set this up if you want as, if I subtract this, I can look at this and say 1,310 minus the integral, if I'm just subtracting this integral over, 18 to K R of T dt. Looking at that, actually as I'm saying this out loud to you guys, that's the expression that I want, because I thought I said, did it say an expression or did it say an equation? Let me reread this. Write but do not solve an equation. Okay, it wants an equation, so then I can set this equal to 0 and there's an equation. This is an equation. Each of those would work. Pay attention to your vocabulary. As you can tell, got to reread sometimes. All right, hopefully that helps.